Hello and welcome to this new video. Today I'd like to talk to you about the differences between traditional routing and PBR, policy-based routing. This video is more suitable for those who are approaching networking for the first time, are studying for the CCNA, or simply want to know more. So, traditional routing basically takes care of getting packets from point A to point B. That's it, end of story. But then we can use BGP, we can use OSPF, and so on, but the concept, the purpose of traditional routing is always to take a packet from A and bring it to B. That's all. Traditional routing, which can even be just a simple static route, is clearly very effective because it's a simple configuration, it works well, and it uses the most logical path. Whereas PBR doesn't necessarily use the most logical path. In fact, it's the network administrator who decides which packets and therefore which networks to send where, how to send them, what type of traffic, what type of port, and so on. For example, if you have two providers, provider 1 and provider 2, and you want web traffic or even all traffic to go through provider 1 while only VoIP traffic goes through provider 2, there you go. In this case, in combination with COS, you can do that. Or failover, let's say you have two or more providers, right? So if provider 1 is unreachable, it switches to the second provider, and so on and so forth. Now I'll show you this small lab setup, which you can try yourself if you want because it's very simple. The lab is down here, here it is, very small compared to everything else. So first let's take a look at the traditional routing table. So for those who are approaching, for those studying networks, so I do show IP route and it shows me this. And I see there's an S which stands for static because there's a static route. All destinations are sent to the provider. Number 1 in this case, which is here, 10.0.0.2, the next hop. Then we have some links, so networks directly connected to the E0, E01, and E02 ports, which are respectively 10.0.0.1. Then we have 20.0.0.1, which is provider 2. And finally, we have 192.168.10.1, which is the network. So it's the link that connects R1 to R2. And up to this point, everything is simple. Well, PBRs aren't difficult. Now, for those who are studying, you always have to remember that routers, all routers, know the networks that are directly connected to them. What does directly connected mean? A directly connected network is, for example, 192.168. 10.0/24. This is a network directly connected to the router. The router knows it. This means that this provider here does not know these networks over here. So if I from R2, so from the router at the bottom, try to ping provider 1 and provider 2, which are respectively 10.0.0.2, I can ping it. And if I ping the second one as well, I can ping it, I can ping both of them. So what do I want to do with PBR? With policy-based routing, I specifically want all of the network traffic that is generated by R2, which isn't explicitly defined or categorized. In this particular scenario, it's essentially all of the traffic, but just to make it absolutely clear and transparent, I will thoroughly show you the complete configuration, which is indeed very straightforward and simple to understand. I want all the traffic generated by R2 to go through provider 2 and not provider 1, and I can do this with PBR, which I'll show you how to set up. Let's go to router R1, which is this one. Under the E00 interface, which is specifically the one that is connected to R2, and then let's proceed to configure our PBR, which is policy-based routing. First thing, the access list. An extended access list in this case, because I'm giving it a name, and I'll call it PBR traffic. Then we tell it permit IP, we give it our network, which is 192.168.10.0/24 wildcard mask, because as you know, in access lists, you need the wildcard mask. We press enter, then exit, we type route map, and we give this route map a name. In exactly the same way as the access list, we tell it permit, because you can also say deny if you want. The number, like 10, can also be 1 or even 100. The important thing is that it has an order, because with this number it will read the PBRs. For example, if you have two providers, provider 1 and provider 2, like in our case, provider 1 will have a route map named ISP1 permit 10, then the same thing for route map ISP2 permit 20. So when provider 1 is unreachable, it will move on to 20, then 30, then 40, because under the same interface you can have multiple PBRs. So let's go back to our configuration and hit enter, then we tell it match IP address. Here once again we give it the name of the access list and press enter. Then we tell it set IP next hop. It shows me next hop 20.0.0.2. So every single time you happen to encounter this particular network address, you should absolutely send it to this IP address, which is the second provider, the next hop of the second provider, and I press enter, done. Then we type exit, interface E00 in my case, and we tell it IP policy. We call the route map again with the same name. This was the IP address. We always give it the same name because everything needs to match. There you go, at this point it's done. Earlier I showed you here that I could, you see it's still there, I could ping both provider 1 and provider 2. Let's try pinging provider 1 and you see that it's unreachable, it can't be reached anymore. Whereas if I try to ping provider 2, it responds. So in this case, all the traffic will be forwarded to provider 2. Then of course, I have commands to check if everything is working, like show route map, for example. I'll show you all of them. And here we see our route map, which tells us that there's an access list called PBR traffic, and the next hop is the second provider in this case. Then we have show IP policy. And we have a policy. A route map policy under the A00 interface, and finally the essential show IP access list, which shows us that this access list has matched 10 times under the same interface. As I was saying, you can also have more than one policy. In this case, I only created one, but you can have multiple policies. For example, you could have a policy for failover and a policy for VoIP. Now, having multiple policies is awesome because you can manage, direct, and manipulate the traffic however you want. The issue you need to keep in mind is resource consumption, because clearly the router has to process all the policies every time, for every packet, for every network. So if the router is a bit small, it might slow down your traffic a little. Also, using too many policies, in this case PBRs, makes things a bit more complicated for you, so they should be used sparingly. Now what happens? Let me show you one last thing. Since the interface here, show run, since our E00 interface, which I repeat is the one connecting R1 and R2 to this policy, it says, okay, every time I encounter this network, I send it to provider 2, perfect. And if I don't encounter it, if it doesn't encounter it, it will use the default route, which in this case is this one. And it will send everything to provider 1. So basically, these are the basic routing policies. You can use them, as I already told you, for VoIP for many applications, but the most common is failover if you have more than one provider. Later, if you're interested in the topic, I could show you how to do it with firewalls, which is very interesting, and so you can manage the traffic however you like. Thank you for watching this video and see you next time.